Hi, welcome again to another episode of Code with Toyo. So this is basically for those that are asking um, Python. How can I use Python for data analysis? How can I use Python for data science and other data related tasks? So you have to understand something. Either you're using Python or R programming languages for your data analysis task, or you're using tools like Excel, Power BI, Tableau, and all sorts of tools. If you're using tools, you could be limited at some point, but with programming language, it's unlimited. You can always control whatever you want to do or control whatever you want to see. So let's say we can usually quickly use Python. Let's assume a scenario. Probably you have a data that has to do with a pediatric hospital, I think, yeah, for kids, pediatricians, and the doctor wants to um, watch the trend of a baby growth and compare the how the baby is growing per month with the baby's weight to be able to say the baby is growing properly or the baby is not growing. Something just a scenario pop up. So to work on data tasks like this, definitely you need your data. So let's just, since you understand what we want to do, we want to plot a trend, we want to check for data, do some analysis. So let's just start. The first things first we want to do is let's have a plan. I like having a plan always. So either you're using your VS Code or you're using Jupyter Notebook. Most of the time for analysis, you use Python environment called Jupyter Notebook, but you can always use your VS Code for most of these things. Why Jupyter Notebook is important is because it gives you the ability to write your code as if you're writing notes. So enough with the story. Let's just go straight into it. So let's say the first thing is want to do an analysis that um, checks and compares babies um, babies growth and weight. So we want to check how the baby is growing and the weight of the baby. So basically, most things you need to do analysis like this in Python is, of course, you need the pandas library. At times, you need the NumPy if you're looking at building it into models. You need the scikit-learn. Actually, if you want to do model, the Matplot, lib, the Seaborn. These are all different libraries or different packages that you can use to do um, what you want to do. So, of course, if you don't have them, you have to do a pip install. But if you have them, let's just import. Let me import pandas. And again, if you watch my previous videos, I'm putting an alias PD, and I want to import the matplot lib dot pyplot as plt. Basically, these two things should work for me. So whenever your data is coming, whether your data is coming as a CSV, a JSON, an XLSX, an XML data, anywhere your data is coming from, for you to do analysis, you must sort of have an unstructured data to be a structured data so that you can establish relationship between the values of the data. So, but for now, we are going to be using a sample data as a Python dictionary. So, a dictionary in Python is just an object that stores data in a key and a value pair. So, you might not understand um, most of these things. If you want to get into the whole programming aspect, you just come to inbox. I will be glad to help you out. So like we said, a dictionary, what is unique to it is that it has a key and a value pair. And how do we depict a dictionary in Python? It is using a curly bracket. So let's just go. Let's just call this data, and we say the data is coming as a dictionary. So this is what it is, a dictionary. So mind you, a Python is a dynamically typed language. That means it's an interpreted language and not a static language. So if you want to learn Python core, just let me know. So we want to have a list of the month and a list of the weight, how the weight varies per month. So you can see if I have my age in months, this is the key. There's a value. The value is an array that says from month one, month two, month three. So I think I should have from month zero. I think there's always a month zero. And the values in your um, months should match the number of values in your weight, just because you don't have an out of index array. So we have 0, 1, 2, 3, 4, 5, 6, which are 7 values. One, two, three, four, five. 1, 2, 3, 4, 5, 6. Let's just add one, maybe a 6.1, for example. So we have the data already. Now our data has come into our environment. The next thing we want to do, you want to convert your data into a Python data frame, a Pandas data frame. Pandas, either you are using a series or a data frame. If you want to use more than one data point, then a data frame, but a single data point, yeah, you could use a series. Again, if you want to learn most of these things, you just let me know. So most people call it DF because it's a data frame, but let's just call it yeah, let's call it DF as well. You can call it anything. A variable name can be anything. So let's just go with DF just for the sake of this video. And we are calling the PD, the pandas that we um imported above, and we need the data frame. That means we want to convert whatever thing we have there into a data frame. So automatically, if before this place I quickly want to see the way my data look like, it will return a dictionary for me. At the end of the day, you see I have a dictionary somewhere below here. Quickly, yeah, I have a dictionary here showing me the months and the weight. So I take out what is on line 12, I come to line 14, and I just want to see what the data is looking like now. So I'm printing DF to see is it structured. You can see how the first one look just a list of dictionary and this. So when I run this, it will definitely return in a tabular format. You can see I have a table having um, some indexes here from 0, 1, 2, 3, 4, 5, 6 location of index location here. Then I have my ages and I have my weight, which are the two variables, and they have different values. You can see in 0th month the baby is a 3.5 kg, in first month 4.2, in this. So we can take a look at this, and as soon as we get to DF, then we can plot um, a couple of things. So let's say we just want to do a quick plot with this and just show the trend of how the baby is growing according to month. So let's just comment this out and just let me quickly comment this out and just say let's have a line plot. Let's use the line plot to show um, um, weight over age. Yes. So to show a line plot, of course, we imported the PLT from above. If you remember when we had the PLT here, import Matplot. That's what we use for plotting, mostly for all your plotting works. You are going to use that. So we are saying from the PLT, you want the plot. If you're using a bar, to be a bar, it's a pi. We're going to check all of those. And what are the data points that we are passing? We are passing the age, and we are passing the weight. That means from this data frame, get age, from this data frame, get weight. And we put a little bit marker to show us breaks as it's changing. So we want the title to be baby's weight over age, which is normal. In the X, this X label means the label on X axis and the label on Y axis. If I run this, I should have a chart in front of me showing um, the trend of how the baby um, is growing. Yeah, so it should show us the plot. And if it's not showing the plot, that's because yes, we plot the whole thing, but we are not showing it. So let's have plt.show so that it shows us the plot you have made. If you run this, you should see it immediately come on your screen showing you how it changes and how the whole thing looks like. You can see at 0th month, the baby is 3.5 days. The baby keeps going. And after the 5th month, between the 5th and the 6th month, there is a little bit drop in the baby's weight. And the doctor could start seeing how these things are changing. So again, if you just want your plots to have something as easy as a grid, you can also always put a plt.grid so that your plot will have few grid lines here and there, and just same thing, just taking the data that we have, structuring it. Yes, you can see you have a grid here. So it's showing that the weight in kg age in months, the baby keep growing, and at between 5 and 6 months there's a drop. So let's just do a little bit change to our data. Let's say maybe here the baby came to 4.0, and here the baby came to 5.8, and the baby 6.5, and the baby came back to maybe 5.2, just for example, so that we can have see what is going on with the baby. Is the baby healthy? So it is doctors that will now decide that based on the trend of this growth, this baby is growing in a healthy pattern, or they will do their thing. All you need to do is just do analysis and let them know. And when they see it, explain your chart to them. They'll be able to draw actionable insight or conclusion from your chart. So basically, that's what you do. You pick a data, you structure it, and just keep on going with it. So let's just add one more thing, one quick thing. Let's say we want to add percentage of growth over the months. So we want to add a little bit distribution of percent of growth. So we can have a new variable that will say, yes, let's just call it change in percentage. It will be whatever weight we have in percentage times 100. Let me quickly comment this out so we don't have it always pop up each time we are checking. So let me print out this. If I print the DF again, automatically you will see the data will now come with a percentage column, which we don't have before, but now we have because we just worked on it. So this is it. So it's giving us some unrealistic values. Fine, it's just an assumed data and all of those things. So let me quickly make sure that this is just maybe two decimal place. So let me just do this. Let me call the round function on it and just round it to two decimal places, and I'll run it again. Yeah, so like I said, it's just an assumed value, so we might just get some negatives here and there, which we're not supposed to be getting. Of course, we are going to. Oh, okay. So this a zero, this is a one, a two, a 3.5, a 4.2, a 5.8. So yes. So if you just want to add a new column to calculate percentages for you, this is one of the ways to do it. You just call um the DF, add a new column instantaneously. You can see now we have age in months, weight in kg, weight change in percentage, and all of those things. So you can do a whole lot of things with Python. Let's say maybe you want to increase the baby's weight by maybe a 0.5 kg. Probably when the data was collected, there was a difference in age of zero point 0.5 across the months, which is a mistake, and you are unable to go to the main source of data and change it, but you need to reflect it in your analysis. I don't want to tamper with the original data set the way it came. You could always do it in your data. So you could come and say maybe increasing weight by zero point 0.5 monthly. So automatically you should be able to do it by with Python. You can say maybe I'll call this increase weight in kg. It will be our weight. Yes, we are increasing each one by zero point 0.5. So if you come again and we print our DF, let's see what we have in our output. Our DF. So running it, you can see now we have our original weight in kg is 3.5 here, 4.2 here, and here 4.7, 5.8 gives us a 6.3, and all of those things. So most of the time, you can do all your analysis in Python, do all your dirty work in Python, and at the end of the day, you just throw it into visualization. So in the subsequent times to meet, I'm going to try as much as possible to tell you what the data frame is, what a series is, what a dictionary is, but you should know this. Most of the time, when your data comes from either an API, if you're lucky enough, you're connecting to a MongoDB database or something, the data comes in form of object, which takes almost the same format as this, and JSON files as well. But some files come in different formats, so you just need to get your data, structure your data as a data frame, then go on with your analysis before you throw in your visualization. So see you in next videos.